Okay, so we're going to go over solving exponential equations with logarithms. And remember, logarithms, the main purpose of them is to solve for your exponents. So let's start off with something simple. Let's say I have 3 to the b power equals 17. Okay, and usually I can write this in a log and just say log base of 3 of my answer, which in this case is 17, equals b. And I can't really think of a whole number. 3 squared is 9, 3 cubed is 27. So it's going to be a decimal between 2 and 3, and I can solve that on my calculator. I can go in here and I can do log base 3, just type it in how it looks, of 17 equals 2.58. So b equals 2.58. And that would be my answer. And that's simple enough. But if I get into more difficult exponential equations, I might have to do some other messing around with my problem. So let's say I have something like 9 to the n plus 10 power plus 3 equals 81. So, for starters, this just looks like a mess. But it's really not that difficult if we just remember what we're doing and just take it one step at a time. And even though this video is about logarithms, okay, don't forget your basic algebra, okay? And so the first thing I want to do is just get the 9n plus 10 power by itself. And to do that, I need to subtract 3 from both sides. So minus 3. So I'll have 9 to the n plus 10 power equals 78. Now at this point, I just have my base, an exponent, and my answer. Okay? And so when I have it simplified like that, I can't really do much else. But to get my exponent down so I can work with it, I can put in a logarithm. Okay, and remember, algebra tells me that I can basically do whatever I want to my equation, and as long as I do it to both sides of my equal sign, okay, it really doesn't change my equation. It'll still be a true statement. So if we remember, logarithms help me get my exponents down, so I can write, basically multiply, let's see. I can multiply both sides of my equation by log, just like that. And I'm just going to leave it as log base 10. Makes it easier. I don't have to worry about a base, all those kinds of things. If you wanted, you could put a base, and I can show you how to do that in a second. But as long as I do the same thing to both sides, it has to be the same base, log base 10 on both of these. It really doesn't matter. Okay, so I can use my power property, which tells me I can take my exponent and move it to the front of my logarithm. And so I would have n plus 10 times the log of 9 equals the log of 78. Just like that. And remember, we're solving an equation, so I want to get n by itself. And so to get n by itself, I want to divide both sides by log of 9. Log of 9. And so on the left side, I can kind of cancel that out, and I'll be left with n plus 10 equals log of 78 over log of 9. And then the last thing I have to do to get n by itself is to simply subtract 10 from both sides. And I would be left with n equals log of 78 over the log of 9 and subtract 10 from all of that. Now, if I asked you to not just simplify it, but if I asked you to actually solve it, you can go back to our calculator over here, And we can, let's see, do my fraction, and I can say that log base 10 of 78 over log base 10 of 9, and then subtract 10 from all of it, and I would get negative 8.02. So n equals negative 8.02. Now I said earlier I could have done a different base. And if I'm going to do a different base, I'm going to want to do the different base of the base with an exponent. So I can move this out here. And instead of log base 10, I can say log base 9 of 9 to the n plus 10 power equals log base 9 of 78. Now I can once again do my powers property and say that n plus 10 times the log base 9 of 9 equals log base 9 of 78. And 9 to the first power is 9. So log base 9 of 9 is just 1. And 1 times n plus 10 is just n plus 10. So n plus 10 equals log of 9, base 9 of 78. And then once again, I can just subtract 10 from both sides. So n equals log base 9 of 78 minus 10. And you're thinking to yourself, that looks a little bit different than what I had before. But let's put it into the calculator. And I can say log, what I have, log base 9 of 78 and minus 10. And I get the same exact thing, my negative 8.02. Now, the reason that these do look a little bit different is if we remember our properties, right? I used to have the property, or I still do have the property, of change of base, which said that log of some base of x is the same thing as log of some new base, we'll say c, of x over log of that same base over b. Just like that. So basically what I've done here is I'm doing the opposite of the change of base. So over here, I have log base 9 of 78. And so I could change it to a new base of 10 and say log base 10 of 78, which is what I have there, over log base 10 of 9. So basically, between both of these, it's just using the change of base property to go back and forth between the two. Okay, this one does look a little bit nicer. It doesn't have that nasty double log fraction thing over there. But both will give you the right answer, and both work just fine in a calculator. All right, let's try one more example. And this time, let's use e to the x minus 1 power minus 5 equals 5. Okay, once again, we need to just remember our regular simple algebra. And let's add 5 to both sides. And so I have e to the x minus 1 power equals 10. And now this time, instead of doing just regular log, which I could do log of base 10 and still, I could still get the same answer there. But to make it simpler on ourselves, which logarithm has an e in it? It has to deal with e. Well, remember our natural log, right, is a logarithm with base e. So instead of just putting a regular log in there, let's put in an ln, natural log. Once again, I can do the powers property and say that x minus 1 of ln of e equals ln of 10. And this is basically like setting my base to something other than 10, like we did on the 9 before. Okay, but this time ln of e, that cancels out. That's just 1. And so I have x minus 1 equals ln of 10. Add 1 to both sides, and I get x equals ln of 10 plus 1. Now, the more we get used to it, once again, you can basically see that what I'm doing here is I'm moving my power up front and then just getting rid of the ln and the e. So from now on, I can kind of just cross it out from there and just say x minus 1 equals the ln of 10. Kind of save myself a few steps. All right, and I can plug this into the calculator just like the other ones. And I can say that the ln of 10 plus 1 equals 3.3. So x equals 3.3. And there you go. That is how we will be solving exponential equations with logarithms.